destroy us from light years away. Another day at the Kurzgesagt Labs, where we answer the most important questions with science. Today, how might civilizations wage war across light years? What kind of devastating weapons could they use? And what would they look like? Meet our two players, a yellow dwarf star system home to a species of primates. Humans, as they call themselves, recently became a technological civilization. They have rockets, nuclear reactors, and memes. How cute. The Smorpions disagree. They reside on a planet around the orange dwarf star HD 40307, 42 light-years away. Smorpion civilization developed earlier than humans, and they have much better technology. They've recently built a Dyson swarm around their star, which gives them near limitless energy. And they noticed humanity, which is unfortunate as the Smorpions are planning a hyperspace bypass through our solar system. So they decided that humanity has to go. Interstellar war is hard though. Front lines, tactics and logistics are meaningless at these scales. It's also fought across time. Decades will pass between firing a weapon and learning whether it hit or not. Sending an invasion fleet is futile. Even if the Smorpions travel at a large fraction of the speed of light, the journey to Earth would take decades or even centuries, and humans would have plenty of time to prepare. If you want to learn more about the mind-numbing problem of war between alien civilizations, we made a video about it. Today, we'll help the Smorpions construct a weapon that is not only extremely long-range and as fast as physically possible, but that will totally destroy everything on Earth, so no human survivors will come to enact vengeance on Smorp in the future. In Interstellar War, you want to win with one shot. Our bird scientists have found 3 Smorpion designs: the star laser, the relativistic missile, and the ultra-relativistic electron beam. All based on real technologies that humans are using in some form already. Let's see how they work. The star laser. As an advanced technological civilization, the Smorpions harness the energy of their star by surrounding it with billions of solar power satellites. This Dyson swarm collects 1% of the star's energy output, a million billion watts, 50 billion times more than all humanity generates. What if all the power of the Dyson swarm, all those satellites, were used to create a star laser? Like any laser, the bigger it is, the longer its range. Human-built lasers use small mirrors to focus, so they have short ranges. The Smorpions could turn their entire Dyson swarm into a collective focusing element 1 million kilometers wide. The star laser has an insane range as a result, enough to focus on target Earth from a distance of over 2 million light-years. Okay, let's shoot it. Countless tiny beams combine into a single huge beam. Laser beams are normally invisible in space, but the star laser is so powerful that light scattering off bits of dust and gas in its path makes it clearly visible in the sky. A gigantic column of green light. The laser travels at the speed of light, which oddly enough is still pretty slow on a galactic level. It takes a whole day until the laser has left the Smorpion system, shooting into the emptiness between stars. It will travel for decades, occasionally melting the odd bit of interstellar dust or asteroid. 42 years after being fired, it arrives without warning. Humans only notice a weird green glow in the sky, and then they're gone. 1% of the energy of a star concentrated into a beam the diameter of Earth, traveling 42 light-years. It burns the exposed half of the planet with the intensity of 3 million suns. The seas boil and evaporate, fires scour the land, and within minutes, Earth's crust begins to melt into a sea of lava. As the planet rotates, it turns into a red-hot hell with no trace of life. After a day, it's all over and the laser dies down. In another 42 years, the Smorpions will know if they've been successful. That's another thing about interstellar war. When you attack, your grandchildren will be the ones to find out if you won. It's like all the bombs from World War II exploding in the 80s and us only seeing the effect today. Okay, the star laser's extreme range, speed of light attack, and ability to melt down any target make it a premier interstellar weapon. But is there something else? The relativistic missile. What if instead of converting the energy of their Dyson swarm into a laser, the Smorpions used it to shoot a super bullet? A relativistic missile, going as close to the speed of light as possible. This sort of weapon is at the limits of what the Smorpion's technology can handle, as it requires loads of a highly dangerous material, antimatter, the evil twin of regular matter. Humans have only managed to produce a few nanograms of antimatter. With their unlimited energy, Smorpions can manufacture it at an industrial scale to build antimatter rockets. When antimatter and matter are mixed, they annihilate, which in more practical terms means there's a big boom releasing gamma rays and plasma. The physics is complicated, but basically, if you have a really strong magnetic field, you can deflect the plasma through a nozzle, just like in the chemical rockets humans use. But it would be much faster. The fastest rocket possibly, basically. Our relativistic missile is much bigger than a skyscraper. At the bottom is the bell-shaped magnetic nozzle 100 meters wide. On top of it are 250 floors filled with antimatter and matter ready to annihilate each other. On the top floor is a 300 kilogram projectile looking quite small, about the size of a person. To stop them getting damaged on the way, the missiles have dozens of sacrificial layers that form a Whipple shield. To make sure they do their job, the Smorpions build 1,000 missiles. Let's fire them. Launching all the relativistic missiles is a spectacular event. For a moment, the antimatter engines lighting up outshine their star. Their exhaust is a long trail of brilliant white, and as they accelerate away, they appear redder and redder until they turn invisible. With the extreme amount of energy released by the matter-antimatter reactions, the missiles are accelerated to 99.9999996% of the speed of light. They have effectively infinite range, as there's nothing really to slow them down. They arrive shortly after you can see them. The light from their launch will take 42 years to reach Earth, so human astronomers might see the flash of the missile's launch, and then a few days later, they'll hit. Not enough time to prepare. Each relativistic missile packs the kinetic energy of a dinosaur killer asteroid, so only one needs to hit. They never reach the ground, disintegrating instead at the edge of Earth's atmosphere. Intense blue flashes set everything on fire. Then continent-sized fireballs slam down on the surface to smash everything into dust, repeatedly, until nothing is left but rubble and smoke. So, interstellar missiles with unlimited range, minimal warning, and delivering complete destruction of a planet's surface. Nice. But
nice.
They are a...
It might come tomorrow, actually, right? Or a couple of days. Might.